Hi, I'm Daryl Taruk from San Beda College, Alabang. Today we will be discussing about correlation and regression on statistics. What is correlation and regression? Correlation is a statistical method used to determine if there is a relationship between variables and the strength of the relationship. Regression is a statistical method used to describe the nature of the relationship if a relationship does exist between the variables. First, we will be discussing about correlation. The correlation is one of the most common and most useful statistics. A correlation is a single number that describes the degree of relationship between two variables. Statisticians use a measure called correlation coefficient. This correlation coefficient measures how closely the points in a scatter diagram are spread around a line. The symbol for the sample correlation coefficient is R. We will show you how to calculate the correlation coefficient using Excel 2013. Given the formula for the correlation coefficient, R is the correlation coefficient. It should be rounded up to 3 decimal places. To get R, we need to solve the value of SSXX, SSYY, and SSXY. SS stands for sum of squares and N is the number of data pairs. And the symbol summation, which stands for sigma, means sum or total. To know the relationship of the correlation coefficient, we need to look at the value of R. The range of the correlation coefficient is from -1 to +1. If the value of R is close to +1, therefore we have a strong positive linear relationship. If the value of R is close to 0, therefore we have a weak or no linear relationship. If the value of R is close to -1, therefore we have a strong negative linear relationship. Or we can use the diagram below as a guide. We will show you how to solve the correlation coefficient word problem. Here is an example. A researcher wishes to determine if a person's age is related to the number of hours he or she exercises per week. First, we need to determine the value of x and y since it is given in the problem. X is equal to the person's age and y is equal to the number of hours he or she exercises per week. And the next discussion will be discussed by Kyle Pangilinan.
Hi, my name is Kyle, and for our next discussion in calculating the correlation coefficient, the first thing we have to do is plot the data in a blank workbook. It will be easier to solve for R if a table of values will be constructed, as seen in the figure below. Next is we have to get the values of xy, x squared, and y squared. So the formula for xy, we have to multiply x with y. For x squared, we have to square x. And for y squared, we have to square y. To make it simple, just select the values and drag them down to get the values of xy, x squared, and y squared of the other data pairs. After getting the values of xy, x squared, and y squared, get the total of the given values. Type in the formula bar equals sum, open parenthesis, then select and drag the numbers to get its total or sum. And close with the closing parenthesis and click enter. To get the total or sum of the other values, just repeat the same process or just drag the total of x horizontally to its right. After getting the total, we will be getting the average of the values x and y only. Same with the total, just type in the formula bar equals average, open parenthesis. Then select and drag the numbers to get the average, and close with the closing parenthesis and click enter. Just repeat the same process with y values. Next is we have to solve for the correlation coefficient. But before that, we have to get the values of SSXY, SSXX, and SSYY. Given the formula, SSXX is equals to the summation of x squared minus the summation of x squared over n. We then type in the formula bar equals, followed by the total of x squared, and subtract it with the total of x, then square it, then divide it with the number of data, which is 6. To continue our discussion, we have Kathleen Atienza.
Hi, I'm Kathleen and we will continue the discussion with SSYY. Since we already have the value of SSXX, we will then solve for the value of SSYY. Given the formula SSYY equals to summation of y squared minus summation of y squared over n. So same with SSXX, which just type in the formula bar equals followed by the total of y squared and subtract it with the total of y, then square it and divide it with the number of data, which is 6. After we have solved for the values of SSXX and SSYY, we then go to SSXY. Given the formula SSXY equals summation of xy minus summation of x times summation of y over n. With SSXY, we type in the formula bar equals followed by the total of xy and subtract it with the product of the total of x and total of y. Then, we divide it with the number of data, which is 6. Since we have the values of SSXX, SSYY, and SSXY, we can now solve for the correlation coefficient, or R. Given the formula, R equals SSXY over square root SSXX times SSYY. Type in the formula bar equals followed by the value of SSXY divided by the square root of the product of SSXX and SSYY. In order to write square root in Excel, we just type in SQRT. Since the correlation coefficient is negative 0.832, which is close to negative 1, we therefore conclude that the correlation coefficient suggests a strong negative linear relationship between a person's age and number of hours he or she exercises per week. And the next discussion will be continued by Janice Bautista.
Hi, I'm Janice, and our next discussion will be regression. So what is regression? Simple regression is used to examine the relationship between one independent and one independent variable. The regression line is the data's line of best fit. The closer the points fit the regression line, the higher the absolute value of R, and the closer it will be to positive 1 or to negative 1. After a scatter plot is constructed and the value of the correlation coefficient is deemed to be significant, then an equation of the regression line is determined. In statistics, the equation of the regression line is y is equals to a plus b times x, where a is the y-intercept and b is the slope of the line. Formula for the regression line. B is equals to SSXY divided by SSXX, and A is equals to mean of Y minus B times mean of X. In order to get Y is equals to A plus B times X. And we should always remember that the values A and B should be rounded up to 3 decimal places. So in order to get the value of Y, we have to get the value of B and A. In order to solve B, we have the formula B is equals to SSXY divided by SSXX. In Excel, we just type in the formula bar equal sign followed by the value of SSXY divided by the value of SSXX. Then click enter. Therefore, we get the answer of B is equals to negative 0.18. After we get the value of B, we then get the value of A, given the formula A is equals to mean of Y minus B times mean of X. Since we know the mean or average already, we just have to type in the formula bar the mean of Y minus B multiplied with mean of X. Therefore, we get the answer of A is equals to 10.499. Since we already have the values of B and A, we can now get the equation of the regression line with the formula Y is equals to A plus B times X. In Excel, we just have to type in the formula bar the equation of the regression line, which is 10.499 plus negative 0.18x. And the next discussion will be continued by Lauren.
Hi, I'm Lauren, and our next discussion will be about standard deviation of errors. So what is standard deviation of errors? Standard deviation of errors tells how widely the errors and the values of y are spread for a given x. What is used usually to denote the standard deviation of errors is the estimate or the sample standard deviation of errors. The standard deviation of errors is similar to the standard deviation, but the mean is not used. The closer the observed values are to the predicted values, the smaller the standard deviation of error will be. So the standard deviation of errors is calculated as SE equals square root SSY minus B multiplied by SSXY divided by n minus 2. In Excel, we just have to type in the formula bar equals square root 2 open parentheses followed by the value of SSYY minus the value of B multiplied with the value of SSXY, and then close with the closing parentheses and divide with n minus 2, which is 4. Then, we click enter. Then we have the answer SE is equal to 1.046.
Coefficient of determination. The coefficient of determination is a measure of the variation of the dependent variable that is explained by the regression line and the independent variable. This measure determines how good the regression model is. It is a statistical measure of how well the regression line approximates the real data points. The symbol for the coefficient of determination is r squared.
To solve for the coefficient of determination, we have the formula r squared equals b multiply SSXY divided by SSYY. In Excel, we just have to type in the formula bar equals open parentheses followed by the value of b multiplied with the value of SSXY, then enclose with the closing parentheses and divide with the value of
SSYY. We just click enter and we have the answer of r squared is equal to 0.6922. This is how we construct a scatter plot. First, we need to select the data pairs and insert a scatter plot, as seen in the figure. After selecting a scatter plot, we then go to Chart Tools, Design tab, and select Quick Layout. We should choose Layout 9 to show the value of y and r squared in the scatter plot. In this way, we get to check our answers.
Again, this is Janice. Hope that our tutorial helped you.